Welcome back, Math 10 students. Mr. Tronis here. We're going to start our new unit, Unit 3. Put your name up there. We're going to be switching gears a little bit from what we've been doing so far in this course. It's been very algebraic, and we're going to get more geometric. We're going to do some trigonometry here. So it's just 4 sections. We're going to learn about these 3 things called sine, cosine, and tangent. And then we're going to use them to find missing sides and angles of right triangles only. And then we're going to apply that to the real world. So let's dive right into our 3.1 lesson and figure out what these things are all about. So trigonometry deals with the relations between sides and angles of triangles. That's the definition. And for this course, we are only going to start dealing with the most basic, which are right triangles, which have a 90-degree angle. You should recall that. They look a little something like this with a little 90-degree corner. And so we name the sides. We're going to need some naming language here to understand how do we determine the different sides of the triangle in reference to a non-right angle that we actually know, or the one we want to find. So we often label this with a fancy symbol called theta that looks like this. Okay, it's the Greek letter theta. Now, let's do a couple examples. Here we have 2 right triangles, and we're going to show how we use this naming. We have our 90-degree angle right here in both of them. But in this first one, we're going to do in relation to angle at A. So angle A is right here. We're going to call this theta. Okay. And so next, how do I name these 3 sides of the triangle? Well, you should remember from a previous course that the longest side, the side opposite the 90-degree angle, is always called the hypotenuse. Always, always. So we're going to name that on both of these right now. That never changes. Now the other 2 depend on which angle. So if this is my angle theta and I go across to the other side or opposite, we call this the opposite side because it's across. And the side that's right beside our angle right here, we call that the adjacent side. So we have the hypotenuse, the opposite, and the adjacent. Now, if we change our reference angle over here to, in this case, angle at B, okay, what we're going to end up having here is, I just want to change colors again. It's not letting me. Switch there. This angle now is our reference angle. So let's call this angle theta. And the side that is opposite of it now, or across, is right here. We're going to call that the opposite side. Okay. And the side right beside it is now going to be called the adjacent. So we can see that the hypotenuse stayed the same, but the opposite and adjacent sides have swapped because we changed which angle we were referring to. All right. Well, let's see how we actually use these now that we have a bit of an idea how to use the naming. We're going to have these special things called trigonometric functions, okay? And they're on your calculator. You must have a scientific calculator in this course. The sine, or abbreviated as SIN. We also have the cosine function, okay, which is COS on our abbreviated on our calculators, and the tangent function. Now, these are special new buttons that you probably haven't played with yet. You shouldn't have, but we're going to figure out how to use them today. And that's abbreviated to TAN. Okay. Now, these are used always to help us find missing angles or a missing side of, again, right triangles. They are simply names for the ratios, okay, of one particular side of the triangle divided by another. So one side divided by the other, which is what this next graphic shows us. So for sine, we can see that we take the opposite side here, right? It's opposite of our angle theta in this case, and we divide it by the hypotenuse. For cosine, we take the adjacent and divide it by the hypotenuse. And for tangent, we take the opposite and divide it by the adjacent. So let's write that down really quickly. We're going to abbreviate it though. We're going to say opposite, or OPP, divided by the hypotenuse, HYP. And we can further abbreviate that even better just to O over H. Okay. And now the cosine of A is the adjacent, or ADJ for short, divided by that hypotenuse. Or we can even shorten that more to A over H. And then over here we have the tan of A, which is opposite, divided by the adjacent side. These special ratios. Ratios are the same as fractions. Uh, and that's going to give us, or we can abbreviate to that as just O over A. Now, when we're using our calculators, we must make sure we are in degree mode, which we're going to show how to use in a moment here. It'll either look like a capital D on your screen or DEG, DEG, okay? D or DEG will tell you that you're in degree mode. If it says R or rad, that's radian mode. You don't want that. So just take note of that. I'll show you in class. Now, this is a lot to memorize. All these ratios, sine is opposite over hypotenuse, cosine adjacent over hypotenuse. That is a lot to memorize. So we have a really easy acronym that's going to help. And it looks like this. We have a big S, and then smaller, we have an O and an H. We have a big C, and we write that as A over H, and then the big T, capital T, with a O over an A. And we read this as SOHCAHTOA. So, S-O-H is, and then Ka, C-A-H, and TOA, T-O-A. So SOHCAHTOA is what we always want to be using and remembering. And let's see how we actually can apply this to some triangles. So example 1 here, I'm just going to rewrite our SOHCAHTOA here. SOHCAHTOA, because I'm going to be referencing it a few times. And so the first time here, it's we have a triangle over here on the right, and it's asking me to find the ratio, okay, of the tangent of angle D. So angle D is right here. Okay, so here's our theta in this case, and it wants to know the tangent. Well, we know from TOA for tangent is O over A, so I need to find the opposite divided by the adjacent, which by looking at this triangle, the opposite is 3. And the adjacent's right beside it here, and that's 4. So 3 over 4, or we could write that as a decimal, of course, and divide them, and we get 0.75. Next, how about the cosine of D? Well, that's Ka, which is A over H. So I need to take the adjacent and divide it by the hypotenuse. So we look over here, we're still looking at angle D. The adjacent is 4, the side right beside it is 4. But we run into a problem here. We don't know the hypotenuse right now. It's a mystery. So we're actually going to call it C. And I know that sounds strange. Why am I using C? Why don't you use the letter H? Because I want you to remember something from middle school that looks like this. A squared plus B squared equals C squared. You're going to use this from time to time. It's called the Pythagorean theorem. And what it's saying is when you have a right triangle, you can square the two shorter sides, the legs of the triangle, so to speak. And if you add them up, it'll equal the square of the hypotenuse, the long side. So that's why I called it C. And so let's plug in these numbers. Let's take A to be here and B to be over here. Okay, so A will be 4 squared and B will be 3. We're going to square that, and we're going to solve this for C squared. So 4 squared is 16, plus 3 squared is 9. 16 plus 9 is 25. And we're almost done, but we have to get rid of this square. Okay, so this is telling me, well, instead of squaring, if I want to solve for C, let's square root both sides. And when we do that, we actually go back to our square root of 25 is a perfect square. We get 5. And the square root of a square, we're down to C. So this side equals 5. Okay, so now we know our hypotenuse, so we can finish this off. Again, you could also write this as a decimal, which if you divided it in your calculator, you would get 0.8. Okay, how about the sine of f? I'm going to switch colors again because specifically I'm changing my reference angle. Now I'm over here for my theta. Okay, so there's my angle F right here. And remember, sine is SOH. So this is equal to the opposite divided by the hypotenuse. Now the opposite of this angle is over here. That's the 4, length of 4. And the hypotenuse we got from the Pythagorean theorem of 5. So it is also 4/5, which is the same again as 0.8. Just happens to be the same as the cosine. All right. Now, we've set up a few ratios here. We've practiced some of the naming, but let's look at 3 similar triangles to find a quick little pattern here. We can see these all have a 90-degree angle. Of course, they're all right triangles, and they all have the same angles. So here's a 53-degree angle, 53 here, and 53 here. Okay. And then they all also have a 37 degree, a 37 degree, and a 37 degree. They have different lengths, okay, on their sides. None of their sides are equal, but that is telling us because we have 3 equal angles, okay, because these are all 90, of course, the angles all match. That tells us we have similar triangles. So let's actually do the sine of 37 degrees. So we're going to do the sine of this red reference angle. And so let's quickly name all 3 of our triangles because we need to know which sides are which. So this is, of course, our hypotenuse. This is our adjacent, and this is our opposite over here. Okay. So I'm going to do that over here again. The opposite is here. There's my hypotenuse and there's my adjacent, again in reference to the 37-degree angle. And over here, here's my opposite. Here's my hypotenuse and here's my adjacent side. So now that we've named them all, let's find out what the sine of 37 degrees for each of these are. So we're going to take the sine of 37, and this is going to be for triangle 1. So let's label that as triangle 1. And so the sine of 37 degrees in this case is equal to, if I look up here, that's opposite over hypotenuse. So remember that, that's the SO of SOHCAHTOA, opposite over hypotenuse. And so our opposite is 4.8, and the hypotenuse is 8. And if we put that in our calculator, we're going to get 0.6. Okay? How about let's try triangle number 2. Now I have different numbers of this on the side lengths, but remember these are similar. They have the same angles. So again, I'm going to take the sine of 37 degrees here. And that is opposite our hypotenuse again. So the opposite in this one is 3. The hypotenuse is 5. Again, if you put that in your calculator, you're going to get 0.6. And you probably guessed it, we're probably going to get the same thing again. So in the third triangle here, we're going to take the sine of the 37-degree angle, and that is equal to, opposite is 4.5, and the hypotenuse is 7.5. So 4.5 divided by 7.5. And guessed it, we're going to get the same thing. You'll get 0.6 when you divide those in your calculator. So what do we notice? Well, now if we use our calculator to find the sine of 37 degrees to 4 decimal places, let's see what we actually get, because these are actually not 100% accurate. They're approximations. So I'm just going to quickly bring up the Desmos scientific calculator here. Now your calculator obviously looks different, and you're going to have some functions that are going to look like this. We have sine, cosine, tangent. So what you're going to do in your calculator, depending on it, and I'll help you in class with this, you are going to take the sine of a 37-degree angle. And you see my result here is 0.60181503232. And it keeps going and going, actually, the decimals. But we can see that we all got 0.6, but there were some more decimals there. So you can see that now we can go to 4 decimal places with our scientific calculators. Again, I'll help you in class with your calculator. Now, I'm not going to go into too much depth, but way back in the day, we used to have to use these tables because we didn't have scientific calculators. I remember using these. We did have scientific calculators. I'm not that old. However, I had to learn how to use these tables. Now, if you still don't get a scientific calculator in class, you will have to use these tables, which is really time consuming. And I don't want to make you do that. But here's what's actually happening. So, when we take the sine of 37, it tells us that any size of right triangle here, okay? We had three different triangles. This side was 37. They're all different sizes, but they all had the same angle. So it doesn't matter what size, the sine ratio, when we determine the sine ratio by dividing the opposite by the hypotenuse over h, we always got the same result. We were always getting 0.6 in that case, okay? Now, this is similar for tangent and cosine too. It's 100% the exact same thing. We're not going to go through that process. That's time consuming, but you would always get the same ratio associated with every angle in a right triangle. Doesn't matter the size, it just matters about the angles. So your calculator has been programmed with all of these numbers, which is really nice. So that's why you need a scientific calculator. And it can go to decimal ranges. These are whole numbers, okay, for the angles. So this is all for angle A, but your calculator, you could put in 3.5675 for the angle. Okay, it doesn't matter. It can calculate it for you. So we can see the one that we were looking at is right here for 37 degrees, and sine is 0.6081. So let's actually use our calculator a little bit more, and let's figure out how can we go backwards. So we can do the sine of an angle to get a ratio, to get all those decimals in that table. But what if we want to know the angle and we know the ratio? So that's what we're doing here. So now that we know that each ratio, okay, should be for a particular angle, we can use this to find missing angles in right triangles. Now, since we're going backwards, we're going to use something that requires us using the inverse, which just means opposite, the inverse trigonometric ratios. And they look like this on your calculator. Most calculators are going to look like sine to the -1. This is called sine inverse, okay? Other ones are going to be cos inverse and tan inverse. That's what the buttons are going to look like. They're probably second functions on your calculator. I'll help you with that. They have a second name that, depending on your calculator, this is more rare, but one they're called arc sine and arc cos and arc tan. Okay, those are the other versions. But most calculators are going to be using this inverse. Okay, sine raised to the -1. That's the meaning we take in the inverse. We're doing the opposite. So here we don't know the angle, it's theta, but we do know the ratio is 0.31. And we can round this to one decimal place. Generally, that's going to be what I'm going to be asking you to do, is rounding things to one decimal place when it comes to your final answers. Okay, so how do we actually do this? Well, what we're going to do is the inverse. We need to take the inverse of cosine. So it looks like this. I'm going to rewrite it. Cosine of theta. And what we're actually going to do is I'm going to take the inverse of cosine on both sides. Okay? Now, if I take the inverse of cosine, this is the same as adding to, subtracting to, or squaring then square rooting. This is going to cancel both of the functions to leave me just with the angle theta. Now over here is where we need to learn how to use our calculator. How do I do the inverse of a ratio, of a decimal? Okay, well that's really easy, and I'll show you with the Desmos calculator, but it all depends on, I want you to learn how to do it on your calculators. So let's clear this. And so my functions again here on this are the inverse buttons. So what I'm taking here is the cos inverse, and I'm going to put in the value of 0.31. And we can see this is my angle. I'm in degree mode. Okay, you can see how much the number changes if I go to radians. You want to be in degree mode. and we get 71.9407 and so on. So I'm going to write that out. Theta is equal to 71.90. Oh, I already forgot what it was. 9407. So it was 94. Let's fix that. Okay. 9407 and so on. Now we're rounding it to one decimal place, so we're going to round theta to be approximately 71.9 because 4 tells me I keep the same number. 9, don't round it up or down. So there's our answer using the inverse. Now over here, I'm going to not show taking the inverse on both sides every time. That's because all we need to understand is that I need to find angle A. Well, that's equal to just taking the inverse of the ratio. So I can take the tan inverse of 2 over 5. So now in your calculators, you're going to take the tan inverse button, you press that, and then you're going to press 2 divided by 5 and then close your brackets. Okay, so I'm going to show again on Desmos how to do this. Let's clear that. So I'm going to take the tan inverse and I'm going to write it as 2 divided by 5. Now this is why I love Desmos. It shows it as a fraction. Sorry, I didn't mean to. Let's get rid of that and close my bracket outside here. And so I can see my degree is now 21.801 is the angle that I've received. I could put this in as a decimal. 2 divided by 5 would give me 0.4. So you can see I get the exact same result. So 21.801. But again, we're going to round that to the nearest single decimal, so 21.8. Now, again, I'll help you with your calculators in class. This will take a lot of practice, but once you get it, you'll understand how to do cosine, sine, cosine, tangent of angles, and then you'll learn how to do the inverse of their ratios or their decimals. So let's do a couple questions here and actually find some missing information. We're going to be trying to find angle G. So angle G is right here. This is what we're trying to figure out. So first thing first, we find our angle. Let's label our triangle. So over here is going to be the opposite. This is my adjacent, and this is my hypotenuse. And it's saying find the measure of the indicated angle. Well, we got to figure out what ratio am I going to use? Am I going to use sine, cosine, or tangent? So let's rewrite our acronym here. So, ka, toa. And we need to think, okay, which one am I going to use? Well, in this case, if this is my angle I'm trying to figure out, what sides do I know? I don't know the opposite. Okay, I do know the adjacent and the hypotenuse values. They're 6 and 14. And yes, we could use the Pythagorean theorem to figure out this side, but that's more work. Let's use the ratio of the information we have. And we know the adjacent and the hypotenuse. We know those two sides, which tells me I'm going to use ka, because you can see that so and toa both use the opposite side, which we don't know that value. So let's use the ratio, okay, the trig function of cosine. So we know the cosine of G, okay, I'll put that in brackets. The cosine of the angle G is equal to the adjacent over the hypotenuse, okay? It's going to be A over H. Now let's put in those values. A over H is equal to 6 over 14 from our triangle. And now we're going to use our inverse function. So we know that G is going to be equal to the inverse cosine of -1 of 6 over 14. We put that in our calculator and we're going to determine that the angle is 64.6 degrees. Okay, again, rounded it to 1 degree. Sorry, 1 decimal place. Okay, let's do another one here. let's find angle X this time. So first thing first, let's label our triangle. There's the opposite. There's the adjacent in reference to this angle X, and our hypotenuse is always across from the 90-degree angle. Now, again, which ratio am I going to use? I'm trying to find X. So am I going to use sine, cosine, or tangent? Well, I know the opposite side and I know the hypotenuse. So this tells me I'm going to use so sine, because I know the opposite over the hypotenuse. Again, ka isn't going to work because I don't know the adjacent side, and toa isn't going to help me because, again, I don't know the adjacent side. So we're going to use the sine function. So we first set it up as the sine of x is equal to opposite over hypotenuse, okay, which tells me that the sine of x is equal to 2.5 divided by 5. And now that we have this, we need to determine uh, using the inverse. So we have to take the inverse of the ratio. Telling your calculator, do the opposite. Find the angle, don't find the ratio. And when I set it up like this, it's going to tell me that the angle X is equal to 30 degrees. Actually, works out perfectly. All right. So again, we've learned a lot of new things in this first lesson. It is a longer lesson, but we learned that we're going to be focusing on right triangles. Okay, we learned these new trigonometric function that are just ratios of the sides and how to name the sides. And we are able to use that to get to use each function to determine these special ratios. But these ratios are actually far more handy when we want to find missing sides or angles, which is what we did a little bit later on by using inverse functions. We found some missing angles. And in the next lesson, we're going to find the missing sides without using the Pythagorean theorem. All right, till next time, we'll see you in class.